In this video, we want to solve quadratic inequalities. So to solve a quadratic inequality, here are the steps. Firstly, you want to make sure that your quadratic inequality is in standard form. So that's the first thing that you'll do. So we'll have something like x squared plus bx plus c bigger or equal to 0. Whatever inequality is there, whatever inequality sign is there. So you want to make sure that it is in standard form. And standard form also means that this a value here must be positive always. Always make it positive, right? So once it's positive, then you have your standard form. Secondly, what you want to do is then factorize. Usually you will have to factorize your trinomial. So let's say you factorize, you get x plus 2, x minus 2, minus 1. All right. So if it was a quadratic, like a quadratic equation, what you would do from here is you would say x plus 2 equals to 0 or x minus 1 equals to 0. Then you say x is equals to minus 2, x is equals to positive 1. That's what you would have done. But it's not a quadratic equation. So quad equation, that's how you would do it. This is a quadratic inequality. So the way we solve a quadratic inequality is that you are going to have to draw a graph. So you draw, this is actually like your x-axis, and then you draw a parabola that is smiling. So you will always draw a smiling parabola. Why? Is because they, by the standard form, we made the a value positive. So once it is positive, that means that it's a smiling parabola that we have to consider. All right. So after you draw your smiling parabola, whatever values that are here, these are, we call them the roots, or you can say the x-intercepts, right? But we refer to them as the roots. Now, those roots are the values that you would get if you did solve it using the quadratic equation way. So you would have got minus 2 and 1. Those are the values that you need to put down there. So I'm going to put the smallest one here, the biggest one there. So you must do that. We don't want to see this. So you can do that on the side. For example, if you're factorizing, you got 2x plus 1. Now you're not sure what the x value would be here or what the root would be. You will say 2x plus 1 equals to 0. So then 2x equals to minus 1. Then x is equals to minus 1 over 2. So that's going to be your root. Okay. So then that will be your step number 3. Then step number 4, we will always conclude it by saying, take this a value minus 2, take the other value 1, and then put an x in between them, and then go grab your inequality sign and just put it like that. That will always give you the correct answer. There is a process to understanding how we get this answer, but for algebra, all we need is just to give them all of this and we get our full marks. All right, so let's go ahead and try out some equations together. Over here, we're going to first start with the standard form. So I'll say x squared minus x minus 12 smaller than 0. Then the next step, I want to factorize this. It's a simple trinomial where I can factorize using the shortcut. I'll say the factors of x squared are x and x. The factors of 12 that can subtract to give us 1 will be 4 and 3. They must have opposite signs. The biggest factor gets the middle sign, which is minus, then a plus. So now I've factorized. The next step that I would do now is to make sure I draw my graph. Okay, so I drew my graph. Then I know that this bracket of x plus 3 will give me, will give me a minus 3. So I put minus 3 there. I put positive 4 there. Then I concluded, I say minus 3, 4, put an x in between them. I grab that sign, and that's my answer. Let's solve it this side as well. I'm going to start with standard form again. I bring those terms over to the left-hand side. I get positive x minus 4 bigger than 0. Then I need to make sure I factorize this. Just to be sure, I'm going to check it out here. 3x and x, those are the factors that I need there. and they must give me 1. So I'll put a 4 and a 1 there. That's 4x, that's 3x. I'm just working out my factors there. So which one must be positive is this one must be negative, so plus here, so negative there does give me positive x. So my factors are 3x plus 4 x minus 1. So factorizing is something that's very important. You need to be able to factorize a trinomial, however method that you are using at school. So then we say that, all right, from here you want to draw your smiley graph, and I repeat, it's smiling because the a value is positive. All right, so we are always going to have a smiling graph. So from here I will get positive 1, and then I'll get 4, negative 4 over 3. And then I take those values, negative 4 over 3, take the other value, put an x in between them, and then we finish it off like that. All right, here's another question. We're just going to go ahead for the standard form again. Smaller than 0. Therefore, we factorize our brackets again. Okay, well, let me factorize y. Okay, so here I'm looking for the factors of 2 that I can add to give me 1. Factors of 2 is 2 times 1. There's no way they can add to give you 1. So that means that you cannot factorize it. Okay, you cannot factorize it. And if you generally cannot factorize it, it means that, well, it can mean 2 things. One, it means that your solution or your roots will be irrational numbers, for example, something like this, right? But in this case, we can clearly see that this value, this c value, is positive, meaning that the y-intercept, so the y-intercept is above the x-axis. So if I were to draw this on a Cartesian plane, okay, so I have my y-axis, I have my x-axis. So we just draw the x-axis. As you can see on this side, we just drew the x-axis only. But in this case, we want to make sure that I want you to see the y-axis as well. And notice that this graph, this parabola, will actually be smiling and cutting the y-axis there too, and it will be a smiling graph, meaning that the a value here is positive. So what that means is that we don't get an x-intercept. If you don't get an x-intercept, you'll tell them it's a no solution, meaning that there aren't any roots. So no solution over here. All right, so let's go ahead and try this one out. Now, for this one, it's already factorized for us. All right, they've already factorized this for us. But now what we have to take a look at is that we have the variables, the t's, we got them positive and negative. So if you look at the other factorization that we did, our variables, the terms with the variables were actually both positive. So that would imply that we started with an a value that was positive. So what I want to do here, if I had it the other way around, let's say t minus 3, and then I had t plus 1. If I had something like this, meaning that this t is positive and this t is positive, I would go ahead and just draw my graph. But I'm not going to do that. I'm going to multiply it all out. I know we can conclude it from here, but I want to teach you with the smiling graph always. All right, so we're going to say that's a problem for us. So let's go ahead and say multiply the 3 outside. You say 3, and then you have a plus 3t. Multiply the t like that, you're going to get a negative t. You're going to get a negative t squared bigger than 0. Then let's simplify these and write it in standard form. So we have minus t squared, which comes first. This 3 minus 1 gives us a positive 2t. And then we're going to have a positive 3. than 0, bigger than 0. Now, do you see the problem is that the a value is negative? So I couldn't conclude from this factorization that they gave me. I had to multiply it out so that I can make sure that the t over here is positive. So we working with the a value of positive so that we always draw a smiling graph. So you're going to say this is t squared. So we're dividing by negative every term, or you can say change the sign of every term. So we say minus t squared becomes positive t squared. Then here we're going to have a minus 2t, and we're going to have a minus 3 bigger or equal to, bigger than 0. Then here we need to factorize. So we're going to get our factors, factors of t, and then we say that we're looking for the factors of 3 that will minus each other to give you 2, which will be 3 and 1, minus and positive there. Now we are happy with this. Now take a look at what we had over here versus what we have over there. In this bracket, so let me highlight them for you. This bracket, we had the t positive, so I could have just easily swapped them around. But for this other bracket, let's highlight it as well. We had the t negative. So I couldn't just swap them around. I needed to take out a negative in that bracket. So if you take out a negative in the blue brackets at the top, you will get t minus 3 with a negative out here. And then you can just divide this whole thing with negative 1, and you divide by negative 1, hence canceling out that negative and getting the same result. So I did this whole step because I wanted you guys to actually notice that this negative t will actually yield a negative t squared, and we don't like that. So we want to make sure we always get rid of that so that we can draw a smiling graph. So over here, the next step is to draw our smiling graph. And then we're going to say that this is minus 1, this is 3. Remember, we're using these brackets to get these values that are here. And then you can say, therefore, and if you forgot, it's t minus 3 equal to 0. So then t equals to 3. And then t plus 1 equals to 0. So then t equals to minus 1. That's where I get these values that I put on my graph. Then I say it's minus 1, 3. I fetch those values. I put an x between them. I fetch that sign over there. And that's my answer. All right. So let's keep it going here. Let's go to this question. So when I look at this trinomial again, I notice the same problem, that this is actually going to be the y-intercept. So I cannot factorize it. And even if you use the quadratic formula, it will give you no solutions. So we're going to tell them that, well, we have our x-axis and the graph is way ahead here. It's way ahead here. You don't have to show the y-axis, but do show it just to show that you understand what's going on there. All right, so then you'll tell them no solution. No roots, meaning. Now this question over here, we have a denominator. We're going to say, therefore, I need to use the LCD. The LCD is x. What do I do with the LCD? I will multiply every term by the LCD. So the LCD is whatever you can see there down by the denominator. So even this 0 is going to be multiplied by x. So then why am I multiplying by the LCD? Is because I want to cancel out the denominators so that I have a sum without denominators. So what I will end up having is something like this, whereby you have x plus 2 minus x bigger or equal to 0. Now, if you notice here that everything actually just cancel each other out, we get we are going to get over here a 2 bigger than or equal to 0. So in this situation, we let's see. Yeah, we can't solve for this inequality as well, because after taking out the after taking out the LCD, we can't solve for this after taking out the denominator, you can't solve for it, because another way we could have done it was to say x plus 2 over x. Then we take that minus 1 over to the other side. We get positive 1. And from here, we can just cross multiply. We get x plus 2 bigger than or equals to actually x. And these guys will actually cancel out. So I'm going to say no solution here as well. No solution. So we can't solve the quadratic inequality, which clearly looks like a linear inequality. All right, so probably we needed to rewrite this sum, but that's it for this video, guys. I will see you in the next one.